Hey guys, Travis Gillespie here. We're looking at geometric sequences, and it turns out that you can generate or find the values of a specific term as long as you have some key information. The things that you'll need to know here: one, you're going to need to have a special formula, this formula that's written up in the corner, and I'll talk about that in a little bit. That's one thing you'll need, but the other things you're really going to need is the value for your first term, and we're going to call that value or that term a sub 1, and the value in this case happens to be 1000. And the other thing you're going to need to know is the common ratio. So let's go find out what the common ratio is of this sequence. In fact, I probably shouldn't say let's find out what it is. I should probably say let's find out if there is a common ratio. So the way we do that is to take a value in one of the terms and actually divide it by the term that's before it. So in this case, I'll have 200 over, and let's fix that fraction bar real quick. 200 over 1000 here, 200 over 1000, 40 over 200, so 40 over 200 here, and then 8 over 40 here, so 8 over 40. And I can actually simplify all of these fractions here, and let's just start with the easy one. I put 400, that should just be 40. So simplify both numerator and denominator by dividing by 8 on top and on bottom here. And I'm going to end up with 1/5. And if I were to do the same thing here, divide both numerator and denominator by 40, I end up with 1/5. And again, divide numerator and denominator by 200 here, and I'm going to end up with 1/5 again. So that it looks like the ratio is constant, therefore I have a common ratio of 1/5, and this is the value I'm going to substitute, or this is one of the values I need to substitute into this equation. So let's get started talking about this equation. So this equation helps me generate or find a specific value in a specific term. So let's say I want to know what the value is in the 7th term. I'm going to find out what it is or generate that value using this equation here. So a sub n, that says, well, this is the term that I'm most interested in. So I'm just going to write that down first. A sub n, n in this case is the term itself, or the index for that term. So that's going to be 7 because we're looking for the 7th term. So a sub n is a sub 7 in this case. A sub 7, it's equal to, the value for a sub 1 is 1000. So I'm going to substitute that in for a sub 1. 1000, and I'm going to wrap that in parentheses here, so 1000's in parentheses. And now the value I'm going to fill in or substitute in for r is the common ratio. In this case, it's 1/5. So times 1/5 times 1/5 raised to the power of n minus 1 here. N, remember, it's the value in the index here, so it's that nth term, which is 7. So n minus, or 7 minus 1 in this case. So 7 minus 1. All right, so let's go through and just simplify this equation now. So I have a sub 7, it's equal to, well, 1000. I have 1000 times, and I'm going to fix that parenthesis there. All right, so 1000 times 1/5 times 1/5, I'm going to wrap that in parentheses, to the power of 7 minus 1. So the power of 7 minus 1 is 6. And before I move forward from here, I don't remember if I read through this equation or not, so let me do that. That would be read as a sub n is equal to a sub 1 times r raised to the power of n minus 1. Okay, so now let's actually go through this equation. I'm just going to clean it up from here. Alright, so a sub 7, it's equal to, a sub 7 is equal to, well, we have 1000 times 1/5 raised to the power of 6, or to the 6th power. Okay, so one way of thinking about this is actually thinking about it as 1 raised to the power of 6 over 5 to the 6th power. So both of these values, 1 in the numerator and 5 in the denominator, both of them are being raised to the power of 6. So in fact, I'm just going to leave it like that here, and just write an extra step out below. Now once you get familiar with this, comfortable with it, you won't need to do it all the time. So a sub 7 is equal to 1000. Alright, so 1 to the 6th power, so times, okay, so 1 to the 6th power times 1 to the 6th power. So 1 to the 6th power is 1, just times itself 6 times. So just simply 1. And 5 to the 6th power, this is where you're going to want to pull out a calculator. 5 to the 6th power is going to give you a value of 15,625. So 625, I'm going to extend that fraction bar sum, and let's just wrap this in parentheses now. And now the next step is to multiply 1,000 by 1 over 15,625. And one way I can do this is just think about 1,000 as a fraction itself, which would be 1,000 over 1, which means I would multiply straight through or straight across on top using multiplying the numerators, and multiply straight across on bottom with the denominators here. So that's my next step, 1 times 1,000. So I have a sub 7, it's equal to 1,000 over 1 times 15,625 will give me 15,625 here. So 15,625. And now I can actually simplify this, dividing both numerator and denominator. You could just divide it 1,000 divide by 15,625 and get a decimal, or you could actually find a common factor for both of these and actually divide by that common denominator or common factor here. All right, so a sub 7, it's equal to, well, both numerator and denominator can be divided by 125. So 1,000 divided by 125 is 8, and let's fix that 8, over 15,625, which divided by 125 will give a value of 125. So this fraction is 8 125ths. That's one way of looking at the answer. The other way is looking at it as a decimal, as 0.064 or 0.064. So in either case, the 7th term, or the value in the 7th term, is going to either be 8 over 125 or 0.064, and you can box that information up.